Hello, hello, hello. This is Cloud Unfiltered. I am your hostess, Nikki Acosta.
Hey, I'm Valor. It's good to be with you again, Nikki.
And we have an awesome guest with us today, somebody who's been at Cisco for a minute, knows a lot about OpenStack, knows a lot about kind of what's happening in the community with containers. It is Vikram Hosakote. Say hi, Vikram.
Hey, Nikki. Hi, Valor. How are you? Thanks, Tom, for having me on the podcast. I'm Vikram Hosakote. I work in Cisco's Meta Cloud team, mainly working on OpenStack and deploying and developing cloud products for cloud customers. I am also working in containers. I'm a co-reviewer of the OpenStack Kolla and Kolla Ansible projects upstream.
Cool. So we usually start these things. And by the way, thank you for clarifying just before we started on how to pronounce your last name, because I've been saying it wrong. So thanks for clarifying. But we were really excited to have you on today. And we typically start these things by asking you about how you got into tech. What were you like as a kid? You know, how did you find yourself on this path that you're now on?
Yeah. So let's see. Yeah, I was always a curious kid, right? I remember I broke open TV remote controls. I used to break open my remote control cars. I used to break open all the electronic gadgets at home. I remember doing that. But as far as computer science itself is concerned, I want to say maybe when I was like 11 or 12, I got introduced to a computer. It wasn't even a Windows. It was some x86 box, and there was BASIC on it. And one of my teachers at school was working on it, and that's when I got introduced to computers and programming. And then I also got a lot of books about programming, like things like Fortran. I also saw COBOL, people working on it at my school. And it all started, back when I was 12, 13, but not very seriously. But then end of high school.
Wait. Quick question. Can you still program in Fortran and COBOL?
No. I started. So I remember when I got introduced to Fortran, there was an earlier version. I think it's Fortran 77. I never understood that. I didn't even understand the syntax. I can probably brush up my Fortran 95 skills. The Fortran 95 is one of my first program languages. COBOL, because they were doing a lot of mainframe and batch processing work at my school. Yeah. So I used to see people working on COBOL, and the thing I like about COBOL is the whole the divisions, right? There's an identification division, there's a data division, there's a procedure division. It was blocks of divisions.
I just like that you're defending and talking about how rad COBOL is. Did you grow up in the Boston area then?
No. I grew up in India, actually.
Okay.
I was I did my schooling and my high school back in India, where my school had a lot of x86 machines. They were working on mainframe batch processing, large transaction processing, mainly on basic Fortran, COBOL, and a lot of books. Our professors working on it. End of high school, I remember I was part of a support team that kind of did support work for all the computers in my school. There were no laptops back then, so we used to do any sort of help as far as computers are concerned, like be disk or drivers. I remember I got introduced to Linux as well. No CentOS, Ubuntu. This was all, I think, Solaris or maybe BSD. I think FreeBSD, NetBSD those days. And I remember we used to help people load drivers for printers or the network interface cards. So that's how I got introduced to tech. And after that, I got into my computer science undergrad, and then did my master's in computer science. And then pretty much that's it. I actually started my PhD in computer science and dropped out after 7 months, and joined a startup because everybody in my research group did that. I also wasn't. I think I wasn't focused to do 8-year computer science PhD. And then I came to Cisco, saw the open source world, started loving it, and in OpenStack now.
So what is it like growing up in India? Because, I think there's this this perception that, you know, you kind of have a destiny to either go into computer science or go into healthcare. Like there's, you know, specific fields that if you're going to college, what was your path like? Is that perception off?
No, you're very right. My dad is an electrical engineer. All my uncles are engineers. Many of my cousins are engineers and PhD. It's not like, I think it's maybe a society thing, or maybe when my parents grew up, the jobs that kind of earned good salaries were like, you know, engineering, doctor, and lawyer, right?
Right.
And for some reason, you know, either it was the political system or the bureaucratic system. Lawyer was, at least in my family, my dad was like, oh, lawyers are fraud, you know, they take a lot of bribe and stuff like that. But in my family, like you got to be like somebody who gets a degree that gets you a good salary end of the day, right? I mean, you can go into humanitarian arts and all of that, but I don't want you to be, you know, asking for more money or come to a basement when you're 35, 40. So it kind of like that attitude. And then, yeah, that's why most of the people are either, you know, engineering, doctor, or even lawyer, mainly because everybody's doing it, right? And they're seeing good results. They're doing great jobs. They're getting good salaries. Yeah. Like I remember people who studied engineering and doctors, they had mortgage and would buy a car in their late 20s. When my dad's generation did a PhD in other branches, and they weren't so financially settled like in the society's eyes. So it's kind of like a go with the flow thing. But if you look at the big picture, it helped me because it put me into tech, and I love tech, so it's worked out pretty well for me.
Yeah, it's good. It's good for you. So let's talk about the tech, man. What's exciting you these days in cloud and everything?
Sure. So let's see. I got involved in open source. Actually, yeah, my involvement with open source is my first step into cloud. That was back in 2011. In my not my previous org, like two orgs before my current organization. We were doing a lot of VMware projects. Like we had VMware products to deploy virtual machines. And I remember back in 2011, we started using or moving from physical metal servers to virtual machines, right? And that was when I got involved with open source, because we were using CentOS virtual machines a lot. Mm-hmm. And CentOS used libvirt, right? And for virtualization, libvirt is the API layer that talks down to the virtualization like KVM. And libvirt was broken in 2011, and they asked me to find a fix. And I started looking into the code. It was C code. And then I told them, I think I kind of found a fix which might work. And then they said, you don't have to find a fix and implement it. And they said, when we mean find a fix, go to the open source community and ask them the fix. And that's when I got the flashbulb. Oh, okay. So that's how open source works. So somebody else does a lot of work for us.
So you had actually gone into the code and you had figured out exactly.
I had, yeah.
You're
I had built my own libvirt version with whatever fix that I was about to test. And then one of my architects, he said, it's an open source project. You don't have to like even worry about fixing or finding the code. You can go to the community, talk to the developers. And that's when I sent an email to the libvirt developers, told them the problem. They sent me a patch immediately, and it worked beautifully. And that's when I started liking open source, just the pure anonymity of open source, right? Like you don't know who is working on it. You don't know where they're from. You don't know their gender. You're like in IRC, for example, when you're chatting, you won't know where they're from, what they're working on. All you know is they like what you like, and they're working on what I'm working on. Yeah. So that's how I got involved in open source back in 2011. My first movement to cloud was in the OpenDaylight project. Yeah, that was back in 2013, where Cisco built an SDN controller. It's called the POX controller, where Cisco had this idea to implement an SDN design, right, to kind of separate the data plane and the control plane. Kind of opposite the traditional Cisco model, where you have a box, the data plane, control plane, routing, forwarding, everything. And then they thought once the data plane is all figured out and burnt into the hardware, the control plane was pretty idle. It wasn't busy. It wasn't as busy as the data plane. And then Cisco thought, why not separate the two things and have a separate box, the disk control plane, which is the network intelligence part, and then the data plane, which is, as they say, the dumber part, like just kind of like the forwarding engine. And that's when
So what's going on with the OpenDaylight project right now?
Oh yeah, it's very active. I was involved in the hydrogen release. That was the first release. OpenDaylight follows the names of the elements in the periodic table. I think they are boron now. They started with hydrogen, I remember, in 2013. That's when OpenDaylight was open source in the first place. And then I think there was helium. Now it's boron. There was carbon. I think carbon is next. But I don't know the order. It's not as alphabetical and easy as OpenStack, really.
It's a H helibib kanofni is the first two rows of the periodic elements. I had to remember that.
Oh yeah, so you know, right? So you know what?
I didn't remember that.
H helibib kanofni. That's how I remember the first two. We had a teacher that made us remember those. Thank you, Mr. Holt. Appreciate it.
So are people really using OpenDaylight? Are people really using OpenDaylight? Because I hear Cisco talk about it, but I don't know that I've heard. And it could be that I'm not looking in that space, but I'm just curious. Like, are you seeing it? Like, and why do people want to use it?
Yeah, OpenDaylight is actually pretty active, especially the latest release, the boron release. So basically, it's kind of different than OpenStack, right? OpenStack is for cloud, right? It's a VM as a service. If a customer wants to replace their metal servers with a bunch of virtual machines and network them, they go to OpenStack. But OpenDaylight is completely different. It's like it's more for like service chaining, for example, or an ideal use case would be like NFV, where there are still virtual machines in an OpenDaylight environment, but they're not as independent and standalone like an OpenStack environment. So an OpenDaylight would have a chain of machines, one after the other, like a virtual router or a virtual switch, like a virtual firewall, a virtual load balancer, a virtual proxy. It kind of, they call it the
service chaining.
The service chaining, or they call it a channel sometimes. So they're all in chains in the OpenDaylight world, and when data comes into OpenDaylight, it goes service after service in the service chaining.
But are there like vendors around it? Are there?
Yeah, Cisco. When I was working OpenDaylight, Cisco did the POX controller, and Nicero Networks, I think, did the Knox controller. They were the initial SDN controllers for OpenDaylight. But today, OpenDaylight talks more than just OpenFlow. It talks like SNMP, talks REST API, talks RESTConf. It even talks Neutron and integrates into OpenStack. That's actually one of my talks and workshops at Cisco Live in Vegas last month. We showed how OpenStack, which is a cloud use case, can be integrated with OpenDaylight, which is a NFV use case, and both can be deployed. So a customer, an NFV customer who wants a cloud can use the integration and get OpenStack, or an enterprise customer who wants a service chain can also do the same and get the other part of the integration. Yeah, it's pretty active. It's not as, the developer community is not as big as OpenStack.
Of course not. Yeah.
And the NFV use cases are not as much, they're not as widely seen as OpenStack. Telecom uses it. Some finance uses it, I think.
Yeah.
But traditional data center, enterprise, retail, all they want is just OpenStack, like a bunch of virtual machines behind a firewall, a private cloud, or maybe a public cloud.
Yeah. So Vikram, tell us what you're working on now. Like what's exciting that you're working on now, and what's the future of it, and why is it exciting to you?
Sure. I'm currently working on 2 projects. I'm in the Lunar team in MetaCloud. That's the networking project in OpenStack. We work on Neutron. We are right now upgrading Neutron to Okata.
Wait, hold on. What's Lunar? Is that
Lunar is just a team name.
Team name. Okay, has nothing to do with any OpenStack projects. Okay.
No. The teams in MetaCloud are like, I think they're based on galaxies or stars, so kind of related to cloud. So they're solar, they're lunar, they're the galaxy.
Okay.
So Lunar team does networking in MetaCloud, works on Neutron. I am also working in the site reliability engineering team, helping the ops team work on production issues. And of course, working on Kolla and Ansible Upstream. I'm a co-reviewer of the Kolla project, so I hang out in the IRC channel and work with the Kolla developers. Because
tell us what Kolla is.
Sure. So Kolla was actually started by Cisco, or maybe I want to say it was upstreamed by Cisco. So Kolla is a project that containerizes OpenStack. It was started, I think, September, October 2014.
What does it mean to containerize OpenStack?
So yeah, Kolla means glue in Greek. It's kind of like different, very different than the traditional deployment model of a cloud. So what Kolla does is it takes an OpenStack service, puts it in a Docker container, and then uses Ansible or even Kubernetes to deploy in the data center. So there are multiple advantages to this, right? So your question was a great question. So why do we want to containerize anything? OpenStack is pretty complicated to deploy. There are a bunch of services, a lot of big files, a lot of defaults, non-defaults, a lot of tuning, a lot of knobs, and then it's a fast-moving project, right? What works today may not work with the newer version of this same project tomorrow. So Kolla or containerization makes it easier to get back to a golden state. So that's very important in cloud deployment. We clearly saw it when we were working on Kolla, because if something works, it's not so easy to take a snapshot of the entire cloud and have a golden copy, right? But Kolla makes it possible. So everything is baked inside something called as a container. And in the shipping world, kind of an analogy is like the shipping world, where if we order something from Amazon.com, it comes in a container or in a box. It comes on the ship from wherever it's shipped from, right? So when we receive it, we will be sure that everything in it works out of the box. If something doesn't work, it's my mistake as a user. So if a container works for me and if it doesn't work for somebody else, it's mostly because it's user's mistake. And that's why container is famous, because it makes developers point fingers at others when something breaks, and no other technology made that possible. Because all these days, if something works in my system, if it doesn't work in your system, I have to come to your system, look at the dependencies, look at what software hardware you're running, and things like that, and fix it. But container completely eliminates that problem, right? Because a container has everything, including the piece of code and the dependencies and the packages and the config files needed for a piece of software. So when it works for me, it has to work for you. If it doesn't work for you, either your hardware is bad, it doesn't do containers at all, or you're supplying the software with some bad, invalid configurations, which is again your mistake.
So Vikram, that's fast. So I didn't actually quite realize that. So Kolla, the Kolla project isn't actually for users to run containers as part of their workflows, like something like Kubernetes provides. It's a way to stand up OpenStack and manage an OpenStack cluster. I get that right?
The OpenStack services, right?
Yeah,
so like
you're exactly right. Yeah, you're exactly right.
Which I heard that, and this might be a gross oversimplification, but the sort of reason intent for containerizing OpenStack services for MetaCloud is that you have the ability to do in-place upgrades that are non-disruptive, which is huge. I mean, at that point, you've got all of your services, they're running a container. You can swap out a service in real time and literally have, less than a millisecond of downtime where the data plane is unable to either provision or decommission cloud resources.
Yeah, that's totally possible. And what Nikki brings up is a great point. That's all post day one or day two activities. And Kolla containers is a great example to do day two or post day one activities in a very easy, reliable way. Like, for example, upgrades, very easy with containers. Just pull in the new container and start them. Reconfiguration, very easy because the software itself doesn't change. Say we want to do some tuning. For example, we were talking how an enterprise cloud, for example, can be tuned to NFV, right? That's a reconfiguration use case, like, do the tweakings or tunings of the configuration and then start the container. That's all, again, day two. Patching, for example, there's a bug. And we need to patch our software. It's not the mistake of the user in this case. It's very easy, fix the software, build a new container, and ask the user to pull a new container. Yeah, everything is easy post day two because we just give them containers. So from an operations point of view, the unit of deployment that's passed around, or what ops receive and what they need to deploy, is now containers. They don't need to worry about what package to install, what dependencies, what config files, what networking, what tweaks, and all that. Everything is baked into the container we give them. And all they need to supply is the runtime things when they start the container, right? Which is called configuration. And OpenStack has like a million configurations, right? When we combine services, you can mix and match and do a lot of self-tunings.
That's one of the drawbacks of flexibility is the complexity can increase sometimes. So what part of this project are you working on? You mentioned that you're an upstream maintainer.
So right now, Kolla is moving to something like a Kubernetes model. The main reason Kubernetes is very, very famous is because it's also containers in the first place, but users don't build anything. If a user wants Kubernetes, they go to the website, they pull the containers that are already built in the GCE, right? Google Compute Engine data registry, container registry. They pull the containers and they start the containers and they use Kubernetes. They're good to go. But with Kolla, it's almost the same with an extra step before starting the containers, which is building the containers from scratch. And that's been a pain for ops because building all the OpenStack services, OpenStack has around close to 100 containers.
Yeah.
And building them takes a good couple of 5 to 6 to 8 hours. And sometimes build may fail because if the register, something's down. So Kolla is going to a model where we give them built golden OpenStack containers that have to work out the box. So they now can use Kolla and hence OpenStack as Kubernetes, like go to a registry, which is Docker Hub in Kolla's case, pull the OpenStack golden containers, supply the right config files, and start the containers, and boom, they get a working cloud. That's way, 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 way more easier than most of the, or I want to say all of the installers I work with. I work with Juju. I started with Cisco OpenStack installer. I've done PackStack. I've done OSAT, OpenStack Ansible deployment. Everything needs a lot of pre-configuration or day zero steps, I'd like to call.
Yeah.
Kolla is trying to eliminate all of that and just pull the containers and run it. It's like, downloading the software and running it, right? Like we want Chrome or we want Slack, for example, in our laptop. We don't want to build Slack from source. We just download it and we start it when we use it. And that's how Kubernetes is, and that's why it's very famous. Just pull it and run it. Nobody needs to build anything. It's for the developer or whoever develops containers 8 to 10 hours a day. It's his or her job to do it. And as a user or ops, I don't even have to know what to containerize.
So wait. So if I'm going to deploy OpenStack with Kolla, then I would need to have just Docker installed, or I would need Kubernetes installed?
Yeah, you need some basic software installed, of course. You need Docker installed. You need Docker Pi, which is the Python client, Ansible installed. Some basic networking needed for Kolla. Any networking needed for OpenStack is taken care of by Kolla's installation. And the good thing now is we are trying to automate that as well. So if you give a very minimum stock, pristine, I want to say like CentOS operating system, for example, with nothing installed, just some sort of IP to get into the box, Kolla's planning to automate the pre-install work as well, like deploy Docker, Docker Pi, Ansible, set up the network, and then pull the golden containers and start it. So as a user, you need to just provide a basic VM or bare metal server.
So here's our operating system.
Basically, something that used to take days and days and days and days and days, now you can do in like minutes.
In minutes, right? And again, this is all in terms of for development environment. If you're looking for a production cloud, the same containers can be used, but the networking part has to be set up, because a production cloud has a lot of computes, controllers, storage nodes, and they have like an upstream devices, like a couple of top rack switches and all sort of bonding going on. Kolla doesn't do any of that. That's in fact outside of OpenStack. So in a production world, I'd say we still want to do a lot of day zero work. That's going to be the case in any automation, right? Containers or not. Like the truck pulls in, the box are, the routers are unboxed, they're racked and stacked, the cabling is done, the power is turned on, the operating system is loaded. That's what's done by the ops on day zero, and then day one is when Kolla started, like pull and run.
So you've spent some time working on private cloud products, both for service providers and then also for enterprise type customers as well. What are some of the challenges or differences between what service providers want and what enterprises want when it comes to private cloud?
Yeah, that's a great question, actually. My work in OpenDaylight, which was mainly NFV and SP, was a good segue for me to move into SP and NFV use case for OpenStack. Like when I started working in OpenStack, my customers were all media customers, which is in a service provider NFV use case. And the project I was working on was called Mercury, which is today called Virtual Infrastructure Manager WIM. So basically, yes, there is a lot of difference for sure. SP, NFV, telecom is a lot different compared to like an enterprise, data center, or retail, something like that, right? Yeah, so as far as differences are concerned, it's just what the requirements, right, are needed by the customer. I want to say a cloud, like an enterprise data center use case, is much simpler in the sense all they want is a bunch of virtual machines networked together, and that's it. They're good to go, and the cloud is ready for use. They run their applications in the virtual machines, and they're good to go. But the SP and NFV use case I was working on was way more than creating a couple of virtual machines. Like they have this concept of service chaining, for example. They have this concept of channel. So media customers, where I was working on, they wanted an entire channel in their data center. The channel is a set of virtual services, one after the other. Kind of a service chain channel, a couple of different terms for the architecture. And when the packet comes into their data center, they want each service to do something to the packet. and then pass the packet to the next service in the chain. Like, for example, virtual router, virtual switching, virtual firewall, proxy, load balancer. They can all be, DMZ. They can all be connected as a chain, and we can we can visualize a chain as something coming into the chain, going through the chain, getting changed in the chain, or doing some sort of work in the chain, and then coming out of the chain. That's very different compared to a data center enterprise case, where it's just a virtual machines, and they don't have much of chaining. There's no dependency as to this has to run after that and that has to run before this. But in service chaining, like, it's a chain. So if we have to run service 1, if that passes, go to service 2. If that fails, go to service 7. If service 7 passes, go to service 8. If that fails, go and retry on service 3. If service 3 passes, back it up on service 11 and then get out of the chain. So something like that.
So is that because of the nature of what service providers are doing, like in terms of just processing huge amounts of data all the time?
Yeah, they provide a service, right? So in the SP world, something is being streamed. That streaming is very important. I forgot to mention that. In an SP cloud, we always see something being served to the client. So for example, Netflix, or I have IPTV in my house, Sling, for example. So a Sling data center is definitely different than an enterprise data center, in the sense when I turn on my TV, a bunch of services need to run in the data center of Sling or Netflix to provide my streaming on my TV. And as long as I watch my TV, like 5 hours, 10 hours, or entire night, those services better be working. It's not like a bunch of VMs running an application. When I change my channel, I may use a different service, or the same service with a different streaming service. Streaming usage, right? That's why multicast was widely used in my work with the media companies, where when we see a TV channel which is broadcast, say, for example, California, I am in Boston, and say everybody is on the East Coast is watching the same TV channel, they don't have to replicate each packet all the way from California to all the East Coast. Right? Like, they don't have to replicate each packet, like California to Boston, California to New York City, California to RTP, California to Atlanta. It doesn't make sense. So what they do is they probably have, like, I don't know, like Chicago or somewhere in the middle of the country, where they send just one stream, and then their data center at the center of the country will have a multicast service chain that knows how many receivers or how many people are watching this channel, and that's going to, like, blast out multicast streams. And you see, this is not possible in a traditional non-service chain cloud, is it? I mean, like how can we do any sort of providing a service at real time with just a bunch of virtual machines? So that's
it's not like a CDN where it's like permanent, like kind of cache there until the TTL expires, right? I mean,
Yep. I mean, you could use CTA in SDN case. Like, you can do content delivery network to delivery content, but something is being provided or serviced all the time. If nobody watches Netflix, then Netflix might as well be an enterprise use case, right? There's no service being provided. If nobody watches YouTube, then they won't need any service chaining. They'll just have a bunch of virtual machines and cloud enterprise or cloud, right?
It's crazy how much we take all this for granted. Like, when I'm like, browsing my phone, late at night, going through things, switching from one thing to another, and I click a button and it's there and it's there and it's there. I don't realize all of the hops or the complexity behind what it takes for that content to be previewed and then executed and delivered to me right now.
Yep. And all these days, imagine that this was all being done by individual metal physical servers. So that's why NFV is taking off, right? And the moment we can do all of these, streaming and replicating packets from California to other part of the country, with just virtual machines, that's way, way, way easier for service providers. And that's why they want to deploy all the services they've been providing all these days in a virtual environment, and they call it a chain. It's like it's a series of activities.
So I'm not a networking expert, but when someone sends content, let's say I'm in Austin, you're in Boston, and I don't know, you send me we start this Google Hangout, right? And we start talking. Is there an option for you to make sure that your data is getting to me on the easiest, shortest, cleanest route?
Well, SP, you're talking, you have to agree.
That's what service providers do, right?
Yeah, UDP, right? Like unreliable. Yeah, that's a very good point you bring up there. Yes, if somebody's going to be servicing a lot of data to how many of our customers, there is an element of unreliability. Imagine doing all of these streaming in TCP with a lot of acknowledgement and sequence numbering. We would take up a lot of bandwidth. And then two, of course, we would get a confirmation that the other end is receiving a stream, but that's a lot of work for the hops in between. So the use case you're talking about, I almost did something like that in the media space with media customer, but they didn't worry about confirmation. So they were blasting multicast UDP streams. And as a receiver of the data, for example, I'm blasting multicast UDP streams. As a receiver, you are okay and kind of sign an SLA agreement that, okay, I can tolerate maybe 5% drop or maybe like 6% drop. I know it's UDP, it's unrelated.
Oh yeah, there's times when my Google Hangout gets a little pixelated and the sound drops for a second, but then it catches up and it's good.
Yeah, it doesn't catch up. Yeah, it's not that once your network picks up, you're not going to rewind and you're not going to automatically see what the video you missed. That's not how UDP works, right? If you miss something, you get a jitter, you lose it forever unless you've recorded it. So that's kind of how TV works, right? You're seeing a Super Bowl and something goes wrong. Users don't worry. They agree that they know that some sort of unreliability is okay, and that's why that's a challenge in this SP world. Like, how can you reduce this element of UDPNS or unreliability in your service provider? Like, you can have fat links, you can have fast links all the way to user. Like, I can get like a 1 gig link to my router if I pay more to Comcast. But not everybody does that. Everybody has a regular household link coming off of some Comcast tower, and it's a challenge to SP that without using a big expensive fat link, how can I reduce the jitter that somebody's streaming, and that's
especially when you don't know what your user's paying for, right?
Yeah. That's a good point. Yeah, you don't know what your user paying for. You don't know what they're seeing. You don't know if it's live or not. If it's recorded, it's DVR, and also depends on the demand, right? Like something like the Olympics or Super Bowl needs a very strong service chain, I want to say, compared to like a recorded movie on Netflix, right? So customers, it depends on the use case. Like if it's live stream, if it's like we want to see the president of the US, like Trump speaking, they better increase their reliability, because if the president is, for example, giving a weekly speech or a daily speech, they won't treat it as they don't want to have as much unreliability as they would see in like a recorded Netflix movie. So this is where QoS comes in, quality of service. Again, an element in the SP cloud that not so common in the enterprise cloud or data center cloud.
Which increases the complexity, and I guess I guess this is why there's a lot of use cases that can't just take out of the box software from somebody. Like they're going to need something custom built that works with everything they've done in the past, that works with how they do things in the future. Like they're trying to take legacy things, then they can't have an interruption, right?
Yeah, that's a very good point. And that's not something OpenStack can do out of the box. And that's why OpenDaylight is taking off, because OpenDaylight provides out of the box working service chains. Like OpenDaylight, is for an SDN NFV customer.
Do you see a time when those are going to converge? I mean, you said you demoed it, but you think we're going to see a lot more of that in the future?
Yeah, I won't be surprised if a lot of customers want integration with OpenStack, OpenDaylight. It's just that it's a matter of time, right? Like an SP customer like AT&T or Netflix, they want a bunch of virtual machines in the cloud like OpenStack. Today, what they're doing is they deploy OpenStack and then they manually configure, like manually tie the two together.
Wow.
But what we showed, it's possible in an automated way. Yeah, it's certainly possible. Like I won't be surprised if the customer wants SP in a regular cloud and a regular cloud customer wanting an SP customer wanting an enterprise VM.
Fascinating. I think just I've heard a lot of estimates on just the number of devices and sensors and things that are going to be online. Something like, was it 1 million devices per hour?
Yeah, the last time I read was like a couple millions. Yeah, yeah, they were doing lots of sort of natting, and I think not all of those devices use public IPs on the internet, but still, there are a lot of devices.
It's a lot of data.
A lot of data, yeah.
A lot of data moving.
Yeah, yeah, that's a great point. All these the smartphone Twitter generation is fueling the SP world.
Those dang millennials.
Yeah. Because
they want everything right now.
Yeah, because when we open Twitter, for example, we see a bunch of handles on the left called trending. That's an SP case because they have to be like serving, receiving, doing analytics at a microsecond or millisecond level to figure out trends. Like yesterday, what was it? Rock talking to Alexa, was it, or some sort of home automation device? Rock, the wrestler, and that trended in like 2 hours. And when the lead singer of Linkin Park died, that trended in like half an hour. And how can they figure out what's trending when somebody dies in some country, in some city, somewhere, without some sort of chaining going on, right? Like they constantly blast or analyze Twitter data, and they send this Twitter blast to like an analyzing chain. And then they come up with this all sort of trends on the left of Twitter.
Fascinating. Internet magic and the things we take for granted, all, of course, powered by the network. Woo!
Yeah.
Fascinating. Well, we are about out of time. Before we go, is there anything else we should know about you? How do we find you? How do we get a hold of you?
Sure. I am available by email, of course. I work at Cisco, so you can contact me with Cisco email. I am available in IRC. I mostly hang out in the Kolla, OpenStack Kolla, Docker, Kubernetes, and OpenStack Neutron channels. You can find my my IRC handle, my email ID, my Cisco user ID is my IRC handle, VHOSAKOT.
Wait, say that one more time.
H-O-S-A-K-O-T.
Hosakote.
Yeah, Hasko. And then, yeah, right. No E. I think email ID is some companies.
Oh no, I may have messed that up.
I can send you my IRC. I am not so active on Twitter. My Twitter handle is /boot because I had to mount one of my very initial projects was to repair a boot directory /boot directory, and I kind of did that. And my Twitter handle is /boot.
/boot.
Yes, I'm not very active on Twitter. I know because if once I become active, I want to spend more time on it. And I don't have time. So
well, I hope that we can hear more from you because you have a way of taking very complicated things and making them sound not so complicated.
Yeah,
and we certainly appreciate that.
Yeah, yeah. And sometimes when I give talks or something, I just tweet about my talk. But other than that, just IRC and email, of course, phone. Yeah, and Slack if you're at Cisco.
Awesome. Well, thank you so much for joining us. We've had a number of guests. I'm not even sure who's next. I'm sure I should know this, but we've got guests lined up pretty much through the end of the year. So
okay.
Thank you to our listeners for joining us. Everybody, say goodbye.
Thank you,
Vikram. Thanks a lot, Nikki. Thanks, Valor. Bye-bye. Have a nice day.
Thanks, Vikram.
Bye.
See you, Nikki. Bye.